Hello, my name is Anna Maslukova. I am medical consultant of Neurosoft company, and today I will demonstrate you TMS EEG techniques. What do we need to perform this technique? First, we need the special EEG amplifier, and I will use our Neuron Spectrum 65 EEG amplifier. And please pay attention, this amplifier is TMS compatible. Also, I will use special electrode caps, and as you can see, the electrode is very thin and flat, and also I can rotate them in any direction. And also pay attention, the shape of these electrodes are not ring. Also, we will use monophasic magnetic stimulator Neuro-MS to evoke transcranial evoked potentials, and figure of 8 coil. I will use soundproof earphones connected to my iPhone with installed special software to generate white noise, because we need to avoid contamination of EEG by auditory response. That's all. I put the cap on the patient head and check the electrode position according 10-20 system. Don't forget about earlobe electrode. I connect electrode cap to EEG amplifier. Run Neuron Spectrum Net software. Create new exam. Enter patient data. And check impedance. Using electrode gel in the seating, I feel the space between the patient head and skin and electrodes. I will use cellophane film to protect a coil from contamination of gel. I'll wrap the patient's head with film. I put on soundproof earphones. I connect earphones to cell phone. Now we are ready to stimulate motor cortex using magnetic pulse, and I ask the patient to relax his right hand, palm up. I loosen the screw On the holder arm, I put the center of the coil on C3 according 10-20 system at 45 degrees to the sagittal line and deliver a single pulse. And observe muscle twitch. If there are no muscle twitch, I move the coil in grid-like pattern around C3 position, and each time I move the coil, I deliver a single pulse and observe muscle twitch. Look. No muscle twitch. No muscle twitch. No. 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 After that, I increase the amplitude of stimulation in 5% step and repeat. No. 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 Yes. As you can see, we can observe muscle twitch, and now I need to find hot spot. I move the coil around this spot and look at which stimulation site we can see the largest amplitude of muscle twitch. This is hot spot. I fix the coil and deliver one single pulse to check the position of the coil. Okay, it's good. Motor threshold was defined as the lowest TMS intensity required to elicit visible muscle twitches in at least 5 of 10 trials with the coil over the optimal skull position. In our case, motor threshold is 31%. To learn more about these techniques, follow the links in the description of the video. Now we are ready for combining TMS EEG, and I generate white noise using cell phone. And also, please pay attention, I will stimulate at amplitude of 120% of motor threshold, and amplitude of stimulation will be 37%. Go to Evoke Potential Settings. Enter the value of average delay as 30 milliseconds. Change the scale in EP trace settings to 200 microvolts and change the sweep speed to 200 milliseconds. Press Record button on the toolbar. Start magnetic stimulation. Deliver single pulses. Make different pauses between pulses, from 2 till 5 seconds. Repeat several times to get enough averages. Typically, 10 to 80 stimuli are required to get good responses. You can change the scale for better visualization. Stop the recording. Markers will be placed automatically. Usually, the best visible peaks are N100 and P180. You can view the results in various ways. To close the exam, press the appropriate button and press Save button. Let's look at the topographical plot of TMS evoked EEG responses. So, what can we see? TMS was applied over the left M1 corresponding C3 in 1020 system, and expectably the response from electrode located above stimulated area have shortest latency and highest amplitude of peak N100, and responses then spread over central sites and contralateral regions. And with increasing distance from the stimulation area, the latency of the peak increases and the amplitude decreases. In addition, we can see responses only in areas that share a cortical networks with a stimulation area. In other words, changes in transcranial evoked potentials, latency and amplitude reflect changes of cortical activity both in local and distal parts of cortical networks. So, I've demonstrated TMS EEG technique. I hope it was useful for you. Thank you for your attention. Goodbye.